This is topic 3, block 1, starting on page 63 of your workbook. First part is going to be a little bit of a review of what we've learned so far. We've seen these pictures on the board already. Who remembers seeing some of these pictures?
Me.
Okay. The map here. What did we deal with on the map?
We had to deal with, like, you were telling us how we could, like, without using the GPS, find our way on the map, or, like, find our way to the destination.
Yeah.
How long, like, transferring inches of feet or miles?
So they gave us a word on the map. It started with an S that we were able to use. What was that?
Oh, no.
Scale measure?
Not scale, just
Oh,
one word.
scale.
Scale. They gave us a scale on a map. This is a scale. Remember, they said they would give me something random, like an inch. It represents 5 miles, and we would estimate about how many miles the trip would be. So this trip ended up being how many miles?
40, maybe
40 miles, but was it 40 inches?
No.
How many inches was it?
8.
8. Okay, so we used scale ratios with maps. This looks like a car at a gas tank. How are ratios used there? What do we do at a gas tank with ratios?
It's the, like, amount of money per gallon.
Unit rates, so amount of money per gallon. I like it.
Price per gallon.
A price per gallon. Zooming in here, they said 8 of these gallons will let you travel how far? 296 miles. So to see how many miles I get per gallon, what are they doing? They're dividing.
37 miles.
So I get 37 miles for each gallon of gas I'm putting into the car.
And also, like, could it show you the,
Ethan and you. Do what?
couldn't it show you the amount, like, the money per gallon?
They could tell you money per gallon, because when I go to a gas station, I look at the sign. What is that number on the sign telling me?
How much you pay for
How much I'm paying
Per gallon.
per gallon. The giraffe. What do we remember about the giraffe picture? Distorted, yes. There's a fancy word for it at most.
proportionality?
Proportionality with that diagonal line. You have something else to
From
add?
tree to tree. It was from tree to tree. It was like the grass from tree to tree. It was
Okay.
two trees on tree.
I don't remember that. So if I made this smaller, when the picture's getting smaller, is it proportionally getting smaller or just
Yes.
smaller?
Proportionally.
How do I know proportionally?
Because it's not
Because
cutting
it's
off
not
anything.
shrinking or stretching
How low can you go?
or skinny.
It is getting proportional because the width and the length are changing proportionally. And the last picture. It's been a while since we've seen this little fella. What did we do with that little guy?
It looks like Slenderman. We did unit rates. We did unit rates and proportion, like
Not
if you
with that
had
guy.
2 width and 4 height.
Uh-huh.
That's what I remember.
Okay. John, what you got? We found scale factor with 2 of those pictures.
We did unproportional stuff. We did, like, we showed how the unproportional stuff it was, and we made it like really skinny, really fat, like really tall and stuff.
So they shrunk the picture. We used these 2 pictures. What did we have to find?
Scale factor.
We had to find a scale factor. And then we were able to find that missing side. Okay, so we've learned a lot so far. We're going to keep learning.
We some smart people.
Oh, we are smart.
Oh, it's so smart.
This image is showing what we're about to start learning.
Oh,
Have you seen anything that's on this picture up here before?
yes.
Not necessarily the picture. I'll mathematically, have you
Oh,
seen
yeah.
some of this? What have you seen?
Link time with
You've seen that before. What did you do with link times width? What did that give you?
height.
What happened when you did a link times a width?
You multiplied and gave me the area.
It gave you the area. So you have seen this formula. Area equals length times width.
And the lift times width times height gives you volume.
Okay, you have seen how to find volume. What do you think this P equals stands for?
Paper. Perimeter.
Perimeter. Remember perimeter. Perimeter is a distance around an object. What would this last one be? Area, yes, but area of what?
Behind.
Is it the same area as this one up top?
Oh, it's half the area.
So what is this area of? What kind of shape?
Half it.
No.
A
This is
rectangle.
area of a rectangle. This is area of a triangle. There's too much background noises. Stop tapping around. Moving. All right. Let's start getting. Oh, we got paint again, and we're gonna mix some paint. They're pouring 1 cup of blue and 2 cups of yellow. And what color did it make?
Green.
Okay. What was my ratio?
1 to 2.
1 to 2. Well, they were nice and they filled in this table for you already, right?
No.
Well, part of it. Part of it they filled in. The next one, they're filling in how much blue paint? 2 cups. How much yellow? 4 cups. And what is my ratio? Did it create the same green color?
Yes.
Why?
Because it's proportional.
Good.
It's half of it. Proportional and has the same scale number. Scale factor.
Here's my ratios. Are they?
They're even.
They are equivalent. So, could I mix another something together to get some more paint? Take a second and fill in the rest of your table with some values. Fill in with the rest of the values that you think. They all should reduce down to what ratio?
1 to 2.
1 to 2. Okay, raise your hand if you have an example that would be the same ratio of 1 to 2. Nyla, what you got?
I got four cups of blue paint, 4 cups of yellow paint, and then ratio of blue to yellow is 4 to 8.
Okay, you said 4 cups of blue and 4 cups of yellow, and you got a ratio of 4 to 8.
No, I had
Did you say it wrong?
4 cups of blue paint, 8 cups of yellow paint.
Okay, 4 cups of blue paint, 8 cups of yellow paint. Does 4 to 8 reduce down to 1 to 2?
Yes.
Yes. Kennedy, what you got?
5 cups of blue paint, 10 cups of yellow paint, the ratio is 5 to 10.
5 to 10. Does 5 to 10 reduce down to 1 to 2?
Yes.
Yes. Ethan, what you got?
6 to 12.
6 to 12. Does that reduce down? I agree. Yes, sir.
7 to 14.
7 to 14. Does that reduce down?
Yes.
Okay, so there are lots of them. I think they already graphed 2 of those points for us. You can take a second to fill in the rest of your points that you found, if they fit in the graph. So fill in the rest of them and see what it looks like. So looking at your graph, do you see any patterns that
Yes.
developed? What'd you see, Brody?
Diagonal.
It created a diagonal with the points.
Mm-hmm.
Okay. Any other patterns you noticed? What'd you notice?
That they were all proportionally.
Okay, well, we don't really know what proportionally is yet on a graph.
For mine, they were like the same amount, like far apart from each other.
They were the same distance from each other? Okay, that's cool.
All of them equal to 1 and 2.
Ooh. Did all of our points reduce down to the same point, 1 to 2?
Yes.
So that leads to my next question that says, look at point 1, 2, and what do you think is unique about it?
It's unique.
Simplified all the way.
It's simplified all the way. What is that word we came up with to call it when I had a 1 involved in a number?
Unit factor.
Unit
Rate.
rate. So this is my unit rate of all the points that I ended up plotting. See, I think 4 here is going to plot the rest of my points. Okay, they're plotting the rest of them. Does 3 to 6 reduce down to 1 to 2? My unit rate? Yes. Did 4 to 8 reduce down to 1 to 2? Yes. 5 to 10, 6 to 12, 7 to 14. It looks like they all reduced down. I already turned the page, but I didn't. So, these are proportional relationships on a graph. If I was to plot a point right there where my finger's shadow is, would that point be proportional with this graph?
No,
Why not?
because it's not proportionally even.
It's not running in the line. If I was to plot a point right here in the shadow of my finger,
No.
I don't know what it's copying.
You didn't copy, right?
Okay.
You copied.
I think it detected my shoulder hitting it. So if I plotted a point right here, is this proportional with the graph?
No.
What if I plotted a point right here?
Yes. Yes.
I'll wait until everyone's paying attention, or I'll just say some names and email this link to parents. If I plotted a point right here on the graph, I still have some people not even watching. If a point was plotted here, is it going to be proportional?
Yes.
Where?
Why?
Because look, it's even.
Is it in line with those?
Yes.
Is it rising and running the same amount?
Yep.
What if I plotted a point right here?
I can't see.
No.
Oh, that's in the middle of the
Because that rise
Yes,
a little.
yes.
Is it, if I was to connect these with all those points,
Yes, that would be.
it would be proportional. If it's hitting a line that could be drawn, it is proportional. If it's not on that line, it would not be proportional.
Would that be
So I have a question. So so the graph. So if you had 1.5 and like 4/6, but they like connected, like would that still be proportional on a graph?
If it's in the line that you drew here,
If it's in
Proportional?
diagonal,
if it's in this line,
it's always gonna be diagonal, right? How would it not be?
well, that leads to the next question. Here are two graphs, a blue line and a red line. The blue line, do you think it's proportional?
Yes. It is.
No.
Yes.
Yeah.
Everyone,
Yes.
look at the bottom, and it just keeps on going.
Peyton, you think it's proportional?
Yes.
Yes,
Blue line, is it proportional?
Yes,
Yes.
ma'am.
Well, is the red line proportional?
Yes.
So what are you determining is proportional then? If you say both of them are proportional,
Like if they're
If they
straight, like
follow.
if they go like this.
they're straight,
Or if
both
they're
are
both
through the
if they're both
origin.
like this.
So does it matter what kind of degrees it's in?
Yes.
Well,
as long as
As
it's
long as it's a
Straight line.
straight line. If it had a kink in the line,
it wouldn't be straight.
it wouldn't be straight. You're gonna deal with kinks in your line in high school. And that's where it gets real fun.
That's easy.
Whoa.
Because then you just get the
You have to come up with stuff. I mean, like where your graphs are curvy.
Oh, that's
And stuff.
mountain giraffes.
So these blue and red are both proportional. And that wraps up our lesson. You have, and I'm probably going to check it before the end of the hour is up, problems 2 through 3, but it's on 3 different pages in your workbook. Problem 2, A, B, and C, you're just writing in words what's happening. You're answering in words on 2, A, B, and C. 3A, you're finishing a table. B, you're graphing it. And C, you're predicting. I'm going to walk around and make sure it's getting done before the bell rings. So you shouldn't have homework. Thanks for listening, and
Bye.
No.
Eat Taco Bell.
like, subscribe, and
Don't kill yourself.
and
Share this video.
what's the bell? What's the bell?
No.
Notifications.